Okay, cool. Let's get math in. 1 minus 0.9 is 0.1 divided by 2 is 0.05. Our degrees of freedom is 15. I get that from taking our number or a total, you can even count those, and subtract 1. That gives us our degrees of freedom. So if I look on this chart, I look at 0.05 and down to 15. In this case, I get, let me draw this just in case you're visual. So our 90% is this. That'd be our 90%. The 0.05 would be here and here. We want to solve for these z-scores, so we don't know how, but the table does, which I like. Okay, so that number is 24.996, and if we take 1 minus 0.05, we get 0.95. 0.95, look at 15, you get 7.261. Cool, now how do I use them? Well, first of all, what are they? Those would be your chi to the left side and chi to the right side. Chi is fancy x in short. Let's write down chi left and chi right. The math formula, wait, is that what I do? No. A little bit more math, cool. Nothing wrong with that. Now the math formula is your degrees of freedom times s squared divided by chi squared right is less than standard deviation. I think that's what it's called. Which is less than, degrees of freedom times standard deviation squared divided by x, or chi squared to the left. In other terms, this number goes there, that number goes here. We have everything right. We have standard deviation, degrees of freedom, and the lower guys. Cool. Degrees of freedom is 15 times 9.326 squared divided by 24.996. And because I'm lazy and not want to write this again, we're just going to do this. Divided by 7.261. I'll plug those into the calculator really quickly. First number, I get 52.19, and the second number I get is 179.67. Alright, we're done, right? Let's make sure we read population standard deviation. we are not done. This would solve for the variance. To solve for the standard deviation, we take the square root. Square root. Whoops, forgot to add that in there. This is the variance. What we're after is turn this into that. Really simple. All you do is take the square root. You already did that. So you should get... Oops, I forgot one. You take the square root of this guy and this guy. So the square root of this one would be 7.224. Square root of this is 13.404. Alright, let's plug it in. Oh, what's those first? 7 point... How many? 2 decimals? 2, 1, and 24.25. Because you round this up, you round that up, you round that up. And then 7.22 and 13.40. Wow, we were wrong entirely. How the hell did this happen? Okay. Where did we make the done goof? Well, we messed up in the very beginning, which obviously means those are wrong, because these are wrong. Let's recheck our math real quick. %. Wait a minute, did I even do it right? Yeah, this is t squared. So 90, or 1 minus 0.9 is 0.1 divided by 2 is 0.05. 1 minus 0.05 is 0.95. Is that what I forgot to do? No, we didn't have to do that. Yeah, so it'd be 0.05. Our standard deviation's fine. Wait a minute. Wait a minute, did I? Oh boy, I might have misled us. In this 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, I knew something was off. Okay, I'm not going to redo the entire problem, but I will tell you what I did wrong. So I had us go to stats, tests, t-interval, data, and we plugged in our confidence level. And that gave us everything. Actually, wait. No, it's correct. What the heck? 36.28. Yeah. Did I really just put 16 just because I felt like it then? I swear I must have. Yeah, 0.9 is your sea level. Apparently I just wrote 16 for the hell of it. Okay, well, that blows.